Okay, good morning class. So today we're looking at trigonometry. Oops, what happened now? So today we're looking at trigonometry. We're looking at, yesterday we looked at reciprocal functions. Reciprocal trigonometric ratios there. So today we're looking at solving right angle triangles. Solving right angle triangles. And these examples are on page 114. And the exercise is examples for exercise 5.6. And that's on page 116. Okay. Yes? Sorry? 10. Yeah, we'll do it now. Okay. So solving right angle triangles. As we said in grade 10, all three ratios are done in right angle triangles. Okay. Later on in grade 11, we will work in non-right angle triangles. Okay. So we told that in a right angle triangle, we can calculate any required side or any angle if we know one side and one angle, or one side and another side. So basically, if we know two sides, we can calculate an angle. We can calculate all the unknown sides from there, or we have one side and one angle. Okay? An angle other than 90 degrees. Okay? So we told we need three pieces of information, but we already know that a right angle triangle has 90 degrees. So the first condition is it must be a right angle triangle. Okay? And then if we have any other two pieces of information, we can proceed from it. Okay. So let's go. So in this lesson we're going to look at given a side and an angle. Okay. So I'm looking at example, and this example is on page 114. Example on page 114. The question says in a right angle triangle. Okay, so as you can see the angle F is 90 degrees. HG is 20, angle H is 23 degrees. Calculate correctly two decimal places where necessary. The first case, FG. So if you're looking at FG, what is FG to this angle? That's your opposite, not so opposite to the angle. What is this of the triangle? It's your hypotenuse. So which trigonometric function uses opposite and hypotenuse? So we got firstly sine, cos, tan, which is also as a hat of also. Okay. So we have the angle. So we got theta. We want to calculate the opposite, and we have the hypotenuse. So which trigonometric function do you think we're going to use? Sine. Sine, as you can see there. All three has been taken. Okay, otherwise, if you're looking at cos, your adjacent is unknown. If you're looking at tan, your adjacent is again unknown. You guys understand? So we write for A is going to be sine of 23 equals opposite. And what's my opposite? FG over hypotenuse, which is 20. Okay. So we know naturally this is over 1. So we cross multiply. So we got FG equals 20 sine 23 degrees. So put that in the calculator. Make sure there's a D on top there for degrees, okay? So that gives an answer of 7,81. You all okay with that? 7,81. Now write that on the diagram as well. Okay. Whoever's phone is that, please put it on silent. Then I want angle G. Angle G. How are you going to work out angle G? We know that angles in a triangle adds up to 180 degrees. Can you see that? So work out angle G. So angle G is equal to 180 minus 23 minus 90, which is 67 degrees. Then I want you to work out FH. So there is FH. So what is this to the angle? What is FH to the angle? The adjacent side. Okay? And what do we have? We have the hypotenuse. We also have the opposite. So any one of the two I can use. But normally, we go with what is given to us. Okay? But if you had used 7,81, you're going to get the same answer, provided that calculation is correct. Okay? Yes, Michael? Pythagoras could have been used as well. You all agree with that? So at this point, you have a choice. It's either Pythagoras, or you can use the trig ratio, which is adjacent of hypotenuse, which is what? Cos. Or I could have used opposite and adjacent, which is tan. You guys understand? So there's three different ways in which to calculate FH. All three is correct. Okay? So in the exam, you can decide which one of the three you want to use. Okay? So which one are we going to use cos? So we say cos of 23 degrees is equal to adjacent, which is HF, over hypotenuse, which is 20. So naturally that's over 1. We cross multiply. 1 times HF, which HF equals 20 cos 23. Work that out. It's 20 cos 23 gives us 18 comma 4. Okay, you got units. You all agree with that? Or as you see, you could have used Pythagoras. Okay, so let's go for C or Pythagoras. What did you notice here? I didn't give a reason. Not so? So we don't need a reason in trigonometry. It's only in Euclidean geometry where reasons are required. Unless the question states with reason, then you must state the reason. Then there's a mark allocated for reason. Okay. We'll go with Pythagoras. It's going to be, remember that was the unknown, the hypotenuse squared, which is 20 squared, is equal to 7,81 squared plus your adjacent side squared. So adjacent side squared is equal to 20 squared minus 7,81 squared, and then I take the square root thereof. So it's going to be the square root of 20 squared minus 7,81 squared. Gives you 18,41. Can you see the same answer as you had there? 18,41. Or I could have used tan, I said, no? So you got tan of 23 equals opposite, which is 7,81 over adjacent, which is FH. We cross multiply, we then get FH, tan 23 is equal to 7,81. So FH, I divide both sides by tan 23, so it's 7,81 over tan 23. Which then gives me, I'm not going to do the second way, I'll show you all three ways it works. So tan 23, don't forget to close the bracket. 18 comma 399, which is 18 comma 4. Okay? Why it's not giving me exactly the same answer as we got here? And if you had gone to 3 or 4 decimal places here, you would have seen that, and that is also different. The reason for that is because this is a rounded off answer. Can you see that? So we've got 8,41, 8,41, or what was it? 8,4. That's all you would have gotten the mark for it anyway. You guys understand?
Yes.
Okay. So now we're looking at the next example, and the next example 2 is on page 115. Example 2 is on page 115. This is still examples for exercise 5.6. Okay. So we are told that triangle ABC is a right angle triangle at B. It's a right angle at B. So the angle B is 90 degrees. Then we are told that lowercase a 16.5. So that I can write in here. That is 16.5. Then you got angle C, which is 16 degrees. Calculate to 1 decimal place lowercase b. Okay. So what do we have? We have the angle. What is this to the angle? The adjacent side. What is this to the angle? Hypotenuse. Can you see that? So which trigonometric function uses adjacent and hypotenuse? You all understand, huh? If it was opposite and hypotenuse, what would we have used? Sine. If you have adjacent and opposite, what do you have used? Tan. You guys understand? But it's to do with the angle. So say for argument's sake you have this angle and we got this given information, then what is that? That is again my opposite. Can you see? So it's dependent also on the angle that we have. Okay. Let's take that out again. So you all agree we're going to use cos. Okay. So we say it's going to be cos 16 degrees equals your adjacent, which is 16.5 over hypotenuse, which is, so it's going to be adjacent, which is 16.5 over hypotenuse, which is lowercase b. You all understand? So what we do now, we naturally put this over 1 and we cross multiply. Not so? So it's going to be b cos 16 is equal to 16 comma 5. So what do I do now? Divide by cos 16 both sides. Not so? So b is equal to 16.5 over cos 16. Okay. Which means to say b works out to be work it out. $17.16. You all agree with that? 17.16. Then we replace this. We put this 17.16. Okay. You all understand, no? Is there anybody that's confused? No. Okay? So then B they want you to calculate angle A. So how do you calculate angle A? Sum of triangles again. Okay, so what do I say? Angle A is equal to 180 minus 90 minus 60. Work it out. 74 degrees. 74 degrees. And then C. Lowercase c. So how are you going to calculate c? So I take this. So I say c square equals 17.6 squared minus 16.5 squared. Or you could have said 17,16 squared is equal to 16,5 squared plus c squared. You guys understand? So I'm going to say first 17,68. Remember, that's the last answer calculated on the calculator. So I press answer, I'm going to get 17,616 square it minus 16.5 squared. Give me an answer of 22,39. 22,39. And then I'll of course carry on. I take the square root thereof. Normally if I introduce square root it will be plus minus. But because we are talking about length, we know it's not going to be negative. So square root of the answer gives you 4,73. It says 1 decimal place, so it's 4,7. This should have been 17, because the question says the 1 decimal place. Otherwise, if you go with 2 decimal places in the exam, you're going to lose 1 mark. Okay, because the question specifically says 1 decimal place. Okay? Any confusion, people? So with that, you can now do exercise 5.6. Okay.